All right. Let's take a look at these, see if we can come up with our axis of symmetry. Remember, that's the line that goes through our vertex. Awesome. So we're using this formula up here, our minus b over 2a. Looking at these guys. On this first one here, what is our b value? $18. Our b is 18. Absolutely right. And what is our a? 1. Good. So when we put it into this kind of formula thing here, we have our x equals the opposite of 18 over 2 times 1. So we're going to simplify that. We have negative 18 over 2 times 1 gives me 2. Negative 18 divided by 2 is negative 9. So our axis of symmetry has the equation x equals negative 9. That means that's the x value of my vertex. That's that vertical line that goes to the center of my parabola, my U shape. Oop. Let's do the same thing on the second one. Looking at b. So equation b, this guy down here. What's that? You can type this whole thing in. Yeah. Absolutely, it should spit out a negative 9. I was just doing it manually. Yeah, you absolutely can type that whole fraction into the calculator. Just don't put the x equals n. Let's do the same thing on the second one. What is our b term? 9. I heard it. It was quiet and hesitant, but it was there. What is our a term? 2. So again, we're going to substitute that into this equation up here. Substituting those pieces in, we'll have our x equals the opposite of our b, so the opposite of 9 over 2 times our a, which is 2. So again, you can type this in the calculator. We can simplify this by hand, because that's going to be negative 9 over 2 times 2, which is 4. And that should be exactly what the calculator spat out for you anyway, if you wrote it as a fraction. If you do this in the calculator, just pulling that up. Second column, third button down, you can put this into a fraction that looks like a fraction, where we have our negative 9 over 2 times 2. Exactly how I wrote it. And it simplifies down to negative 9/4. So you can absolutely use a calculator. It's totally fine. You should get the exact same thing. You can even put it in with the operations. Absolutely valid. All right, one more up here. I'm going to switch the order of things I ask up. What is our a? James Gonzalez. 3. What is our b? Close. Negative 12. This minus sign goes with the b. So for our axis of symmetry, we're going to have our opposite of our b, negative 12, over 2 times our a, that's 3. And again, you can type that in the calculator just like that, even with the double negative going on, where I have my second column, third button down fraction. The opposite of negative 12 over 2 times 3. We should get a positive 2, Because what this is this is going to have us be our opposite of negative 12 is positive 12 over 2 times 3, which is 6. 12 divided by 6, 2. So honestly, doing it by hand takes about as much time as doing it in the calculator, just because of the time it takes us to type things in. So either way is fine, totally works. This gives us that x value of our vertex. This tells us where the middle of our table is going to be. Helps us find that vertex. We also have our standard form here. If we looked at that c value, we'd find our y-intercept. We get all kinds of information from this type of equation. We're going to practice working with them the way we did on Friday. Given an equation, we're going to find our axis of symmetry. We're going to find our vertex. We're going to find our intercept, that kind of jazz. And we're going to do one with a standard form equation. So like we did Friday. We're going to do one with a vertex form equation, which is how we did our absolute values back in the last chapter. And we're going to do short problem. So it's kind of the plan. So on page 3, number 3, which we didn't get to on Friday. And a lot of times in this packet, we may not do every single problem because we'd rather have too many problems and be able to skip some than to be able to then have to like come back and redo something. So this should be the middle one on page 3. If you don't have enough packet, I have extras up here. By the way, before I get going, the chapter tests are graded in N. They kind of came in bursts. They were either pretty decently good or they were kind of a struggle. So, kind of came in 2 clusters. And for a lot of the ones that we did pretty decently good on it, those are my friends that are paying attention and taking the notes and trying on the homework and turning in the homework. And those of us that struggled a bit, maybe we need to work on improving some of those skills. Unless we really, really, really want to take this class again. Because it is kind of required for graduation. So, I mean, I'm happy to see you guys again, but I don't think most of us want to take the same class more than once. Because it's your time, your grades. But I'm just saying, if you don't want to hang out with me again and learn the same exact stuff, that might be time to put our phones away.
You teach pre-cal, right?
I do teach pre-cal. I do teach the dual credit pre-cal.
I better have you next
So
year.
that's going from regular algebra 2 up to dual credit pre-cal is challenge mode. It is noticeably harder. So I was like, I'm game if you're game, but it's jumping up to honors. Okay. So let's take a look at this one here. We've got our minus 2x squared minus 4x plus 1. This is the equation we're given. They're calling it k of x. That's just a name. Remember, whenever we have an f of x or an h of x or anything like that, that is y in disguise. He's wearing a cheesy mustache and has a name tag on that says, my name's Kevin. It's still y. He's just given himself a k name. He's Kevin. He's pretending. It's just y. So anytime we see this kind of notation, this is called our function notation, it just means y. Doesn't change anything. He's just being weird.
You said page 3,
Oh, did my page number look different? Page number 3. Can I give you one second? Yeah, I give you one second. That one. That's from the last chapter.
right?
Yeah, that's module 2. You want module 3?
Oh,
Sometimes they're gonna have the heavy ones in there. Oh, there's another module 2. Oh, thanks for finding that. Sure. I don't want that. All right. Cool. On to this one. So the first thing we want to do is we want to figure out what is our A, what is our B, and what is our C, because we need those pieces to find lots of our things. So if we look at this equation up here, just like we did in the bell work, we want to find where we found our A and our B. We're going to find all 3 here. What is our A for this one? -2. It's this guy in front of our x squared. What is our b for this one? Going to be that -4 that's with the just x. And our c is the number all the way on the end that doesn't have an x with it. In this case, it's just the 1. So remember that when we're thinking about our a, b, and c, that's what our a is always with the x squared, b is always with the just x, and c is always by himself, hanging out on his own. C is an independent letter, doesn't need no x. Okay, so we're just kind of playing match up for finding our a from our x squared, our b with our x, and our c all by itself. So the axis of symmetry is 100% what we just did in the bell work, where we're going to take our x equals the opposite of b over 2 times a. So we're going to have the opposite of our b, -4, over 2 times our a, which is -2. So we're going to substitute those pieces in. And then we're going to simplify that. And again, you could put it through the calculator. We could do this one by hand. It's not too awful to do by hand because the opposite of -4 gives us a +4. 2 times -2 gives us -4. What is +4 divided by -4? Not 0. -1. 4 divided by 4 is 1. 4 divided by -4 is -4. So what that tells us is that when we're looking for our vertex here, the x value is going to be -1. Every single time, that axis of symmetry is going to go through the middle of my shape. So where x equals -1, that is going to be the middle of my parabola. So we can even put on our graph that line where it folds to make our parabola. That's going to go right through my vertex. Somewhere on that little line is my vertex. Again, you don't have to do like super much to graph that up. Dotted, solid, not a huge deal. Just don't make it super dark. There, I'm just gonna switch to little dots. There we go. That's where our parabola is gonna fold in half. So we know it's gonna be centered on that. So to find our vertex, to find the y value of our vertex, what we're gonna do is we're gonna take the fact that we know our x is -1. I have my equation that's supposed to tell me why. We're going to plug this thing in. So we're going to take our -1 and substitute it into that equation. And this is one of those times when it probably will be handy to use our calculator, because I don't want to have to do it myself or by hand. Just need to be able to see my equation. So I'm going to go into my calculator, and we're going to have our -2 times our x squared. Well, we know our x is going to be that -1, and it needs to be squared. Then we have our -4 times x, and we said our x was -1. And then we have that +1 that's just tucked on the end. So I can take that whole equation and type it all in. Boom shakalaka. 3. So this tells me the y value when x is -1 is going to be 3. So our vertex is going to be at the point -1. That's not a pen. There we go. 3. So -1, +3. Right here. This is my vertex. That is the middle. That is where it starts. That is home base. Where is our y-intercept? Do we remember? We talked about that on Friday. Remember, y-intercept happens when x is 0. So where might our y-intercept be? What do we get if x is 0? 1. Our y-intercept is always going to be at C. Every single time. So if we're in our standard form here, that's my y-intercept. When x is 0, my minus 2 times 0, that's 0. Minus 4 times 0, that's 0. Plus 1, we get 1. So my y-intercept is over here at 0, 1. That's this guy. So then the next thing we're asked about is our a value. Well, we already found that one up at the very, very top. We needed it already. So our a was -2. Does that mean our parabola is going to be happy face, opening upwards, smile? Or is it down, frown, sad, bad news? What do we think? If a is -2, are we going to be up or down? Down. Because it's been reflected. So we know this parabola is going to open downwards. Whenever our a is negative, bad news makes us frown. If a is positive, yay, good news, smile, everything goes up. So since we know this opens downward, meaning it kind of is going to look like this-ish, does this have a maximum or a minimum? It's going to look kind of like this guy. It's going to have a max. We know it opens downwards because our a is negative. So this is going to have a maximum. That maximum will happen every single time at our vertex. Our maximum is at that -1, 3. So we know this is our axis of symmetry. So that means everything that I know on this side is going to be mirrored over here. I know this point is also going to happen over here. So I can mirror them and kind of get more information. This guy has to match exactly over here. You don't need to have this little line right there. But that little point, this pink point, has to match exactly over here. I could find another point and find more values and exactly match them up. And in fact, that's what I'm going to do to finish out this graph. Is I want to know the y value when x is 1. And you could make a table. We could substitute in values, do all that jazz. But if I know what happens when x is 1, that means I'm also going to know what happens all the way over here because, again, they're going to mirror each other. So if we substitute this into our equation when x equals 1, which is in fact almost what we'd had here, all I need to do is get rid of these minus signs and then I'm exactly with substituting in 1. Boom, lazy mode, -5. To get copies of the equations you've already put in, you go up to the one that you want and just hit enter and it'll copy your whole equation back down into the writing line so you don't have to rewrite. So a little shortcut on the yellow calculators. But when my x is 1, we get a y of -5. So we're going to use that. I know the point 1, -5 is on my parabola. 1, -5 is over here. This point is 2 steps away from my axis of symmetry, so I know it's going to match up over here, 2 steps away from my axis of symmetry. Okay. I didn't. I was a good inch away. It's just grumpy and trying to guess. So we know that this one's 2 steps away. So this one's also going to be 2 steps away. I could do more. I could find what happens at x equals 2. I could find what happens at x equals 3. And if we need more points to see what's going on, we absolutely can do that. Right now I can see what's happening. And we can see that this is, whoa, way too chunky of a pen. I substituted my 1 into my equation. I picked 1 because I wanted another point. So we had these 3. I wanted more so I could get something down here. So I wanted to know what happened when x equals 1 so I could figure out where this point was. And then I typed that in my calculator. We substituted in 1 in place of x, and we got our -5. So when in doubt, we can always put more points in. totally cool. This gives us our graph. What is our domain for this picture? Remember, domain is everything to do with our x's, which means how far left and how far right. It'll be negative infinity up to positive infinity. And in fact, that will be the domain for every single parabola we graph ever. 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 That is always the domain of a parabola. So anytime we have an x squared, a quadratic, it will have that domain.
For every last one of them.
Every single one. What is our range?
Negative infinity.
Negative infinity up to
Negative infinity.
3. The very highest it can go. I get the thought because we got both arrows pointing down. Totally valid. But we go from our lowest up to our highest. Our highest place we can be is 3. So technically it gets a bracket. I am not going to be petty about bracket versus parentheses. But since 3 is a number, it gets a bracket. Okay, so that's very, very much like how we did Friday. Questions on this one? Okay. We're going to do the next one, number 4. Which is similar, but not exactly the same. Because this one's not in our standard form or in our general form. This is more like how we did our absolute values. This is much more like our when we did these guys. Can we see that? Okay, that's it's much more like these guys. The only difference between the absolute values and doing it with a quadratic is instead of having the absolute value bars, it has parentheses and squared. It's the same exact thing. So we still have our h and k in here, our a still in here, all that jazz. So the first thing we're going to do is, again, play match them up. We're going to find our a, but this time I'm finding h and k, not b and c. So what is our a here?
Negative.
Negative 1/2. What is our h here? Close. I heard a whisper of one. Positive 3. This is where we always have that h has the opposite. And what is our k? 1. So it's the same pieces we used when we graphed our absolute values. And in fact, the place where we started on our absolute values is the exact same place we're going to start here. It's going to be our vertex. Where is our vertex going to be? I'm just going to jump to that one first. Where is the vertex? 3, 1. It comes from these guys. It's our HK. This was the middle on our table when we do our absolute values. It's the middle on our table for parabolas. It is the middle. That gives us our vertex, 3, 1, h, k. That's our vertex. So I know the middle of my graph is going to happen at 3, 1. This guy's my vertex. Which means just by knowing my vertex, I actually also know my axis of symmetry, because my axis of symmetry goes through my vertex and always has that same x value. So like we used the x value of our axis of symmetry to find our vertex before, if we know our vertex, I know my axis of symmetry because it is just going to be our x equals h or x equals 3. Our axis of symmetry is always going to be the x value of our vertex, and the x value of our vertex is always the axis of symmetry. They work together. They are a team. And in fact, they will look kind of like that because it's where our parabola kind of mirrors itself. So since we use that reflection to help us draw our pictures, I like to put that line up here so we can see it. That's where everything's reflecting across. Everything's going to be very matchy-matchy over that line. So the next thing they ask us on this one is the y-intercept. That's only when it's in standard form. Because remember, our y-intercept happens when x is 0. So what happens if we substitute in 0 for x? Well, we can put that in the calculator. We have our fraction, that minus 1/2. And we usually have that x minus 3, but I'm going to put 0 in place of the x. So 0 minus 3 squared plus 1. So I can find my y-intercept old school just by substituting 0 in for x. If 0 is x, that's going to tell me my y-intercept. So our y-intercept is going to happen at -7/2, which is not super easy to plot. So I'm going to hit the little 2 arrows above the equal sign and switch it to decimals because that is way easier to graph. -3.5, I can find. -7/2 requires a lot more thought. So when we're graphing, switch things to decimals. It's totally valid. But our y-intercept is going to happen at -3.5. And so we can put that on the graph here. 0, -3.5 is going to be about here. But again, we know this mirrors. I know this piece is 3 steps away from this line. So it's going to also be exactly the same place over on this side. These are going to mirror each other across this little green line. So because I know that this one is over here, it's going to be exactly matched over here. So I can use that to find a whole nother point here. So what is our a value on this one again? -1/2. It's that a value we found at the very beginning. That a value is the same no matter what's going on. So does this have a maximum or a minimum? A maximum, because we're upside down again. So we know it's going to look like this. I could find more points in here. I could figure out what happens at x equals 1. I could figure out what happens at x equals 4. I could find more values. I also, when they're kind of looking like this, I also can kind of just see what's happening here. You can see that. On the last one, they were so close together, it was really hard to tell. This one, they're not as super close together, so I can kind of just rock it as it is. Remember, we're drawing U shapes, not V shapes. Do not use a ruler on these. The more points we have, the better it's going to work. But that much is enough to get through. So 2 last questions on these. What is our domain? Remember, our domain has everything to do with our x values, how far left, how far right. What's our domain? -infinity to +infinity. What's our range? -infinity to the 1. Yes. That's our y values. It's right. It's right. So domain is how far left, how far right. Range is how far down, how far up. So I can go all the way left as far as I want. These are going really far down, but they're also going out. It's continuing outwards. It's just going down really fast. We're going to look at one more. There's no graph. Because sometimes we're just given stories. So this is at the top of page 5. Again, there's nothing wrong with the ones on page 4. I don't want to try and sprint through them. What's up?
I'll go for the rest of them.
Yeah, let me write your best. So we've got here the story of a ball being thrown off a building. And we're asked to find some information. So we're told that the ball is being thrown straight up. I'm standing on top of the building and I'm going to go like this and let it fall. And they found the equation for us. They straight up give it to us. So if it helps, sometimes it does. Here's me. Aha, I'm so good at drawing. I'm going to take my ball and I'm going to throw it off the building. And we are asked to try and find the maximum height and find when it's going to get there. So if we want to find the maximum height, what point is this? The vertex. The maximum height is going to be our vertex. So all we need to find is that vertex. We're given our equation. We're given the equation in standard form. So if we want to find our vertex, how can we do that? Well, our vertex is when we're going to have our x equals that axis of symmetry, our minus b over 2a. Since we're in our standard form here, we're going to have to find our axis of symmetry. The only thing different between this equation and this equation is normally we have x's in here, but this time we have t's. So if they replace the x's with t's, I can switch this x for a t. That's totally bad. This is going to tell us that t, because that's normally where we have our x's. So we can fill in these pieces. What is the b value here? 64 over 2 times our a. What is our a? Negative 16. So if our b is negative 64 and our a is negative 16, what is this t value? What is negative 64 over 2 times negative 16? That's negative 64 over negative 32. Positive 2. Again, you could put this whole thing in the calculator. Totally valid. Or we can mark it by hand. So we know for our vertex here, it's going to be at 2. So when does the ball reach the maximum height? At 2 seconds. How high is it at that time? How could I figure that out? Plug it in, plug it in. You probably used the minus sign instead of, you gotta use the negative. You guys, looks like you got it on the bottom, yeah. So to get the actual height that it's gonna be, we're gonna substitute in that 2. So we'll have our negative 16 times our 2 squared plus 64 times that 2 plus 144. So we can type that in, put that in the calculator, and we'll get that our height is actually going to be 208. So the maximum height is 208, and it took 2 seconds to get there. So when we're trying to find a maximum, that means we're trying to find that vertex. Okay, so on the back of homework 1, there is a story problem. And in fact, there are 2. Where we're trying to figure out that maximum. Okay, finding maximum means finding vertex. So, homework 3-1, I'm going to get announcements up.